Okay, hello guys. In this video I will be teaching, well, not teaching, you've already learned about this stuff. This video is more of just a review, simply going over Unit 2. So, I have Unit 2, Lesson 2 pulled up. There was no Lesson 1, so not going to read all of this, but just skim through the main ideas. And an atom is composed of subatomic and particles called protons, neutrons, and electrons. And if we look over here at this mastery map, atoms atomic model was further developed by Rutherford, which was the gold foil experiment. And then we can go back up here to atoms, and into this branch, particles outside the nucleus can be found, which are electrons. They can be found outside the nucleus of atoms. And then back up to atoms, particles, parts of the nucleus are made up of protons and neutrons. So just remember, when you're talking about electrons, protons, and neutrons, electrons are outside of the nucleus, and protons are inside the nucleus, as well as neutrons are inside the nucleus. They are what makes up the nucleus. Okay, so skimming through this next part, experiments lead to increasing understanding of the atom, as we will find out. Ernest Rutherford set out to test Thomason's plum pudding model of the atom. Rutherford found some experiments yield unexpected results. He did the gold foil experiment, and he discovered the nucleus of an atom. Now, here's a definition that we should keep in mind. A proton is a positively charged particle found in the nuclei of atoms. So, when remembering this, just think proton equals positive. You can also think of it this way to help you remember. The first few letters in proton spell pro, and if you're talking about pros and cons, pro would be a positive thing and a con would be a negative thing. So a proton would be a positively charged particle. James Chadwick presented evidence that the nucleus was made up of protons and neutrons. Now, if we're looking at this definition of neutrons, an electrically neutral particle with approximately the same mass as a proton found in nuclei of atoms along with protons. So, if you think of neutrons, they have no charge at all. They are electrically neutral. So we'll just write N for neutral. And excuse my sloppy writing, but if you look at the highlighted part, neutral, you can see this first part. It sounds like it's starting to spell neutral. And you know, in neutral, it means it's neither good nor bad, nor positive nor negative. So neutron being neutral, having a negative charge, that's a way you can help remember it. Scientific study leads to the understanding that an atom is composed of 3 subatomic particles. which, as we know, those would be electrons, neutrons, and protons. Almost all of an atomic's, let me restart. Almost all of an atom's mass is in the nucleus. So, since we know protons and neutrons are in the nucleus of an atom, the electrons are on the outside. So, see, the proton has a charge of +1. The mass of the particle is 1,836 times more massive than an electron. The number of particles, it depends on the element, and we will get further down into how you can identify the number of protons in an element in further videos to come. Location of an atom is part of the nucleus. Just remember, protons and neutrons both make up the nucleus, and electrons make out the outer shells. They are not within the nucleus, they are outside. The electron has a relative electrical charge of -1. Its mass is least massive of the three. It is about the same number of protons, so if we were going to ask, how many protons does the element sodium have? However many protons are in that, the same amount of protons would equal the same amount of electrons. Like I said, we'll be discussing that into a further video. And the location of this is outside of the nucleus. Now, neutrons, like we said, they don't have a charge. They're neutral, so they have a 0 charge. They are about the same mass as a proton. The number of particles can vary. Smaller atoms have fewer than larger atoms. And yet again, we will be getting into how you can tell the amount of neutrons in an element in a further video. Now, they are also part of the nucleus, so they are right down there with the protons, so pretty straightforward. The number and ratio of subatomic particles within an atom will determine the properties of the atom. So, if you look at this helium atom right here, notice there are 2 electrons on the outside, and they're negatively charged. And notice the 2 protons and 2 neutrons in the nucleus. We can draw a model of an atom. So, 1 proton, 1 electron, and that's hydrogen. Helium, 2 electrons, 2 protons, 2 neutrons. Carbon, 6 electrons, and I can't count how many, but quite a few. Well, going on a random guess, I'm going to say that there are probably 6 since there are 6 electrons, I'm going to say there are probably 6 protons as well. And as for neutrons, there could be 5, there could be 6, there could be 7. I don't remember off the top of my head. Well, this is the end of this lesson, but it says 3 subatomic particles make up an atom: protons, neutrons, and electrons. The names of Dalton, Thomson, Millikan, and Chadwick, and Rutherford are etched into scientific history. Rutherford's gold foil experiment contributed immensely to our knowledge of the atom. He found that positive charges were located in the center of the atom. He called these positively charged particles protons. Rutherford and others proved that other neutral particles existed, and those particles were named neutrons. The nucleus contains most of the mass of the atom in the form of positively charged protons and neutral neutrons. This nucleus is surrounded by a cloud of negatively charged electrons. And here is the mastery map we went over at the beginning. So, hope you found this video helpful. And tune into my next video so as we go over lesson 2.3. Thank you for watching.